Sailing is a very popular activity as it can be both for leisure and relaxation or as a sport. One material that is often used to build sailboats is wood. Wooden sailboats have a long history. They were used since a long time ago, especially by travelers. In 1200, the Vikings used wooden sailboats to explore other lands. Nowadays, most wooden sailboats are used for fishing and traveling by fishermen, and also are chosen for their classic look. However, wood is not the best material for building sailboats. Wood is heavy, which makes it slower than other boats and might cause it to sink. When a wooden hull is exposed to water, the high moisture content and warmth makes the wood rot. Also, wood can be prone to burning, especially if the wood is old. The answer is carbon fiber. Carbon fiber is an advanced material used in the aerospace industry. It is also used in sports equipment such as skis and bicycle frames. It is also in use for sailboats because of its suitable properties for sailing. The properties of carbon fiber are high stiffness, high tensile strength, low weight, high chemical resistance, high temperature tolerance, electrical conductivity, low thermal expansion, non-flammable, strong, non-toxic, non-corrosive, and fatigue resistance properties. In the late 1800s, Thomas Edison used carbon fibers as lamp filaments. This was made by carbonizing cellulose-based fibers such as cotton or bamboo. These carbon fibers were heat-resistant but lacked tensile strength. Later on, the high tensile strength carbon fibers were made using rayon or polyacrylonitrile fibers. What material is used to make carbon fiber? Polyacrylonitrile is a polymer made out of acrylonitrile monomers. Acrylonitrile is a compound made out of carbon, hydrogen, and nitrogen atoms. These atoms are linked in a covalent bond because they are all nonmetals. The formula for polyacrylonitrile is C3H3N. Carbon fiber is made during a long manufacturing process. The first stage is polymerization, where the acrylonitrile powder is mixed with another plastic and reacted with a catalyst. The plastic is then mixed with a liquid chemical solution and pumped through tiny jets into a chemical bath where the plastic solidifies into fibers. The fibers are then washed and stretched to the diameter needed. The second stage is stabilization. In stabilization, there are three steps: cyclization, dehydrogenation, and oxidation. In cyclization, the cyanoside groups form cyclic rings with each other after being heated up. In dehydrogenation, the cyclic rings become aromatic pyridine groups because the carbon atoms lose hydrogen molecules. In oxidation, the fibers pick up oxygen molecules and rearrange their atomic bonding to a more thermally stable ladder bonding. This stage forms hydroxyl, carboxyl, and carbonyl groups on the ladder polymer. The third stage is carbonization, where the fibers are heated in an inert atmosphere without oxygen, because oxygen makes the fibers burn and reduces the end result of carbon fibers. In carbonization, the fibers lose the non-carbon atoms such as hydrogen and nitrogen atoms. The fibers are now 90% carbon. The last stage includes surface treatment and sizing. In surface treatment, the fibers are oxidized by putting the fibers in liquids such as sodium hypochlorite or nitric acid. In sizing, the fibers are coated with polyester resin and then wound onto bobbins. The carbon fiber used in the sailboat is a composite, consisting of a matrix and a reinforcement. The carbon fiber reinforced polymer uses epoxy resin as the matrix and carbon fiber as a reinforcement. The sailboat uses carbon prepreg, which means that the carbon fiber has already been impregnated with activated resin. How is the carbon fiber applied to the sailboat? The sailboat uses a one-piece skin over a mold. Firstly, to make the cutting of the carbon fiber shape easier, a template is made. It can be made out of any soft cloth. The template is then placed over the carbon fiber cloth, and a marker is used to trace over the edges. The marked area of the cloth is cut out, then placed onto the mold. After that, the backing ply is cut and placed on top of the surface ply and molded to the mold. The backing ply is only for additional reinforcement. After all the prepreg material needed is stuck onto the mold, the next stage is cutting release film. The template should be placed on the release film, and the shape of the template should be marked out. Cut the shape out and stick the release film onto the prepreg material, making sure that it covers everything. Next, cut a piece of breather cloth large enough to cover the prepreg material and stick it onto the prepreg material, using masking tape to secure the cloth. The next stage is to cut a piece of bagging film and seal 3 edges, leaving one edge open to put in the molds. Put the molds into the bagging film. Cut a small hole in the film and put the device that takes out air inside. Seal the open edge of the bagging film and the vacuum bag is finished. Connect the device inside the bag to the vacuum pump outside. Remove some of the air and position the bag so that it covers everything. Remove the rest of the air. The next step is placing the vacuum bag into the oven. The prepreg will be cured for about 8 hours. After curing, take out the molds and let them cool down for 1 to 2 hours. After cooling down, take off the release film off the parts and take the prepreg material off the mold. There are many benefits of using carbon fiber to build a sailboat. A carbon fiber sailboat has a higher mechanical and fatigue strength than other materials. It has a high strength to weight ratio, which means that it is stronger yet lighter. It also has high speed and buoyancy due to its light weight. Since it is very strong, the boat is stable and would be safe in dangerous conditions. Carbon fiber boats are very stiff, and they resist degradation even when facing high fatigue. They are unreactive even in corrosive environments, and if made correctly, are very durable even if their environments are harsh. However, just like any other material, carbon fiber has its limitations. Carbon fiber is extremely expensive, which is why there is not much carbon fiber products on the markets. It is also difficult to manufacture because it takes a long time to prepare the materials and cure the carbon fiber. Finally, carbon fiber can be quite difficult to recycle. Carbon fiber is linked to an economical factor. Carbon fiber sailboats are incredibly durable and long-lasting due to its strong and fatigue resistance properties. Due to these reasons, carbon fiber sailboats can be quite expensive. The whole manufacturing process takes quite a while, and there are several steps to go through, which contributes to the price. Due to its price, carbon fiber sailboats would be mainly available for the rich people. Making your own carbon fiber parts at home is difficult to do, so most products are made in factories. The materials are quite difficult to get compared to wood, which is commonly found. To solve this problem, companies such as easycomposites.co.uk are selling specifically made materials that can be used easily to make carbon fiber parts. Scientists are also searching for new ways to make carbon fiber easier to manufacture and to make carbon fiber parts more affordable for everyone. Carbon fiber is one of the newest materials that can be used to make sailboats. Without it, we would not be able to make these advancements in water travel.